trying some new camera angles. I hope this records my audio because the camera's above me now. You're above me. So today's project is to build. I should have brought one down here. Actually, I do have one. I built a container for these. I've got 3 of these. I've actually got 4, but the third one's in a little different shape. So I'm gonna build a box that fits in the big case, where these can like basically lay in here like that. I'll have a little support on the end. I can have 3 of these laying side by side in this little box within a box, container, sub-container, I don't know what you want to call it. So I just got through cutting all this stuff in the shop. This is just masonite. This actually, you can use this for cheap melamine. It's not got a great finish, but you can use it as a dry erase. So I'm going to glue this up using, okay, so this is the former that I 3D printed. It's the test volume for the see if these radios actually fit. So, and this is essentially the size of the, yeah. So let me get the radios out of the way. So the back is going to have this little U-shaped piece. So the radio and the antennas will sit in here. This will stay in here. This is essentially just to strengthen it. I can't put one up here. I may have to put one up here on the other end on probably the outside, because the 3 of these radios fitting in here is going to be really tight, I believe. Yeah, that's going to take up all the space, which is good because I don't want them shuffling around much. I may have to put some foam in ahead of them to keep them from sloshing back and forth, but sliding back and forth. Okay. So first thing I'm gonna do, I'm just gonna glue this stuff. I'm probably gonna glue it with the dark side in because that's gonna take glue better than that slick side. It's not for aesthetics. I don't really care what it looks like. I can paint the whole thing when I'm doing anyway. So there's not much glue surface on this end because there's not a support ring inside. So I'm going to have to do something on the outside here to support this on essentially the same thing as that wood piece, and I may just double up this stuff and put a band of this on top. The glue will hold enough that I can take the forms out and then work on this end once it sets up. But actually I better get this support out, or it's going to glue in there too. Yep. So now let's let that set up. I'm not going to touch it. So we'll go on to another topic. Ready for that? Okay. So I was going to put an IEC connector on the back on this power supply. Well, I wasn't going to put one on there. I was going to use one because I thought it came with one. It does not come with one. It's just a direct wire. Should pay more attention when I order things. Not a big deal. I just a 3-prong adapter that I've stripped. I cleaned the ends off here, and I always put tape around the end to make sure that insulation doesn't continue, in case there's a cut in it. It doesn't continue to to open up. So makes it a little prettier too. So I'm going to tin the ends and hook up this little power supply and see what. I've never used one that has a charging port on it. I've used MeanWell supplies. This is it's a decent little switch mode power supply. I just don't know how the battery charger circuit works on it. This is supposed to be similar to a UPS, according to the description when I bought it. It's LAD-120A. If you want to look one up, I may put a link in the description as well. But for it's 12 volt. It's 8.7 amp 12 volt supply, and I don't know. It's got a 1 amp battery charge on it, and my only concern is if you turn the power, like if you lose power, if it goes into its UPS mode and it switches to battery, how much can it draw? Will it potentially draw all 8.7 amps off of your battery, or is it only going to pull that 1 amp, or somewhere in between? That's the question here. I don't know if these are going to quite fit underneath those terminals. We'll see. I always tin these too long and then trim them to lengths. So, where's my screwdriver set? Okay, screwdriver is not in the set. This is just a standard North American plug, 120, 115, whatever you want to call it. And it's line, neutral, and ground, which would be black, white, and green, respectively. Yeah, that may not. Boy, it just barely does. I shouldn't have tinned that, because my tin, when I soldered the end there, it's a little thick to go past the screw, but it does make it. It'll make for a really strong connection, that's for sure. Okay. Neutral connection. I'm sure I'll take this back apart before it's done. I need to put little ends on these, some little forks, terminal ends. That make this easier. I also want to figure out how these switches work. I know this switch turns the whole power off. It turns the line voltage off. This one, I'm pretty sure disconnects the battery, but I want to make sure that this works like I think it is before I start wiring it. So, unlike Electro Boom, I do not want to see sparks now. I think he does it for dramatic effect. I don't want any. Okay. We got an LED light, so we're on. Power status is good. Let's see where we have voltages. 20 volt DC. So V positive should have positive 13 volts around there. 13.78. And battery positive should have the same. Yeah. And it does not. Wonder why that is. If I turn the battery off or on, doesn't make a difference. I get 4.2 volts. Well, Shouldn't be getting any AC, but I'll check it. No, no AC.
Hello.
Hello. Okay, not AC there, so I'm going to flip it up to 200. I don't want to blow my meter here. We should be getting there it is. 121.8 volts.
But I need a nuclear reaction to generate the 1.21 gigawatts of electricity.
1.21 gigawatts! 1.21 gigawatts!
So we got to figure out this battery thing here. This circuit may be smart enough that it doesn't actually load up unless there's a battery attached. Okay. I don't have the right color hookup wire. This is a little 20 gauge wire that I've got just for, but these colors don't really match any standard, so yeah. Put the screwdriver down again. I've lost it. Okay, let's try, see what our voltage is on the battery. If these connections are good, then we should have around 12 to 12.5 volts here at the terminals. Okay, I got 11.9. I'll take that. I still have my battery, my voltage in, so if I have 11.9 and then I'm going to turn it on. Let me get some computer. Okay, there we go. I still have 11.9, which leads me to believe it's not charging. Turn the switch off. That doesn't seem to do anything. Now I do see a voltage adjust here. I don't know if that's the battery charging voltage or if it's the main output voltage. Guess there's only one way to find out. I really don't want to mess it too much in case it's the, so if I bump this, yeah, even if I crank it all the way, it pretty much was all the way, almost. Yeah, I don't know about that circuit. Okay. These are so screwy. I have to keep reversing the leads because the AC is one, the DC is another, and even the batteries. No, the batteries actually. Okay, so there's the battery negative. Maybe that still wouldn't have mattered. No. What? Why does it show negative voltage? It's battery positive, battery negative. Probe positive, probe negative. Common VCC. Why am I showing negative? Unless it's that's positive. Make sure the battery's not charged backwards. That is possible, but I seriously doubt it. No, it's right there. And that's positive to positive, negative to negative. Oh. One moment. I'm an idiot. If you watch this channel very long, you already know that. I hooked the battery up backwards. Hope that didn't mess up anything. That may be why it's not charging. I think this thing has a circuitry in it to determine if there's a load on it or not. And so it won't put out voltage if there's not a load. And if it's like smart chargers are these days, it won't put out a charge if it doesn't see the correct polarity. I don't know this, but the circuitry to do that wouldn't be that much. So that may be what is going on here. I hope it's that. I hope I didn't just mess this up. Okay, there's 11.8 in the positive. That's what we wanted. Turn this on. That's exactly what it was. It sees a load and it's putting out 13. That probably won't go. It is going to go away to 13.8. So it's charging at 13.8 and it's going to put out at 13.8. If I can get on the right terminal here. Yeah, 14. That's because I messed with the voltage adjust. Yeah, let's trim that back to 13.8. Trimmed it a little much. $13.8 even. Okay, so now we want to know is if I turn off the input, I should still have, I don't know, amperage. I really need a current, I need a current source or load source. Is that right? I need an adjustable load is what I need. If I turn this off, I should still have at least 12 volts, whatever the battery voltage is. So now I'm essentially tied to the, and now if I turn off the batteries, yeah, it drops. So, which that's a good feature because, when I mount this, I'm going to have it mounted where it's close enough I could at least, this AC, I don't care about turning this on and off because I'll turn it off when I unplug it, but I need to get to this switch. So when I'm done, I can turn the battery off and disconnect the batteries from this charging circuit. Okay, let's get on the terminals there. Now there's something. If it's on and the batteries are on, I heard a little relay that time, then it's charging. Now if I turn this off or if I pull it from the plug from the wall, it loses AC, but it latches and keeps the battery drawing down. Now if I flip this off or if the battery disappears and then comes back, essentially, it won't come back and start charging again, or sorry, it won't start pulling from the battery. So if I turn this off, voltage drops. If I turn it back on, it just continues to drop. Right now it's just draining the capacitors. That's a pretty smart little feature there. Okay, so I did find some power resistors. These are 10 watt, 8.2 ohms in parallel. Resistors in parallel are divide or add as reciprocals. So that's 4.1 amps, or, sorry, 4.1 ohms. Oh man, that's already on. Oh, it's because the battery's on. Wow. Let's turn the battery off because that's getting hot quick. That's pulling, if my math's right, that's pulling about 3.4 amps. And it's getting very hot because it's dumping about 12 to 14 watts of power out of those two. And I know you can't smell, it's not smell-o-vision, but it smells hot. So let's see here. Let's see if the voltage is, if I have the battery off, as soon as I turn that on, I get 13.8 ohms, volt, and the temperature starts rising. Yep, there's definitely voltage there. I've also got voltage here. Okay. Now my output voltage is should stay the same or close to it. Okay, it does drop. It's dropping because this is a heck of a load on that little battery, and it's not fully charged, but it is still It's still maintaining about 10.1 amps. Volt. I'm sorry, my units are way off. It's 10 volts. Oh, I can't say the amps and ohms. But it is dropping quite a bit. Pretty fast. But it's doing that fast because it's actually pulling 3 amps. I wish I could see that. I think this actually will do. Let me turn the battery off. Let those resistors cool down. I think this thing actually does show DC amps. I never use that mode. If I touch here and V negative, I'm getting 3.3 amps, which is what I was expecting. So now the test is going to be, I'm going to do that and I'm going to simulate a power failure. And immediately drops because the voltage is, like I said, we dropped the voltage to 10 a while ago. So 10 divided by 4 is 2.5. So it actually is dumping more than the charge current, which is what I wanted to know. Will it drop enough? Will it actually flow more current from the battery than what it's putting in the battery when it's operational, which is good. So essentially what that means is, let's turn that off, turn the battery back on, or sorry, turn it on, so I can charge the battery back up. Move the probes around, change the setting on this old style, and I should be back up getting 13 volts, 12.8, yeah, sorry. It is actually 13.8, but it's getting quite a bit of a voltage drop across this battery. It's trying to pull the battery up to 13. So that's normal. That's going to work. Thanks for coming along. Thanks for putting up with my stupidity. And please leave a comment, like, subscribe, hit the bell icon. I put out kind of sporadically, so to catch on an even, to catch my stuff, it's best to throw the bell icon on so you get a notification. And I'm interested to hear some comments. Please comment on what I'm doing wrong, because I want to know if the comments work. I was silent for 2 years. I'm not sure the comments still work. But anyway, thanks for coming along. Appreciate you following, and I'll see you on the next one.